Hi students, today we are going to discuss about unit cell. That means here cubic unit cell. Cubic unit cell means just like a cube. That is, it consists of 8 corners, 6 face and 12 edges. Just like a cube. 8 corners, 6 face and 12 edges. Okay. Then here the position and contribution of atoms in corner, contribution of atoms, that means 1 by 8 part of an atom. Then face occupies 1 by 2 part of an atom. Then edge occupies 1 by 4 part of an atom. Then what is unit cell? Unit cell means the number of repeating units are arranged in a crystal lattice to form a crystal. This repeating unit is called unit cell. Number of repeating units are arranged in a crystal lattice to form a crystal. This repeating unit is called unit cell. Here we discuss about cubic unit cell. Cubic unit cell. Cubic unit cell consists of 8 corners, 6 face and 12 edges. And the contribution of atoms at corner is equal to 1 by 8, and face 1 by 2, then edge 1 by 4. Then what are the different types of unit cell? Then unit cells are classified into first one, primitive cell or simple cubic unit cell, that is SCC. Primitive cell or simple cubic unit cell, SCC. Here atoms are arranged at the 8 corners of a cube. Atoms are arranged at the 8 corners of a cube. 8 corners of a cube. Clear? 8 corners of a cube. So number of atoms per unit cell equal to how much? 8 corner into 1 by 8 part of an atom. 1 by 8 part of an atom. Because the contribution of atoms at corner is equal to 1 by 8. That is equal to 8 into 1 by 8. How much? 1. So the number of atoms in simple cubic unit cell is 1. In simple cubic unit cell, atoms are arranged at the 8 corners of a cube. Clear? Then second one, unit cells are classified into first one, primitive cell. Then second one, non-primitive cell or centered cubic unit cell. First one, in centered cubic unit cell, first one, body-centered cubic unit cell. Body-centered cubic unit cell. Body-centered cubic unit cell. Body-centered cubic unit cell. That is BCC. Here, atoms are arranged at the 8 corners of a cube. 8 corners of a cube. Okay. 8 corners of a cube. And 1 at the body center. 1 at the body center. Atoms are arranged at the 8 corners of a cube and 1 at the body center. So, number of atoms per unit cell equal to how much? 8 corner into 1 by 8 part of an atom plus contribution. What is the contribution of atoms at body center? That much. That is 1. That is 8 into 1 by 8 means plus 1. That is 1 plus 1, 2. The number of atoms in body centered cubic unit cell, how much? 2. Non-primitive cells are or centered cubic unit cell are classified into 3. First one, body centered cubic unit cell, that is BCC. Then in BCC, atoms are arranged at the 8 corners of a cube and 1 at the body center. So the number of atoms per unit cell equal to 8 into 1 by 8 part of an atom plus 1, that is 1 plus 1, 2. Clear? Then second one, face-centered cubic unit cell. Face-centered cubic unit cell. Face-centered cubic unit cell. Here, atoms are arranged at the 8 corners of a cube. 8 corners of a cube. And the center of each face. This is the face, then face center. 1, then 2, then 3, then 4, then 5, then 6. Clear? So, number of atoms per unit cell equal to number of atoms per unit cell equal to 8 corner into 1/8 part of an atom plus how many faces? 6 face. Then contribution of atoms at each face is equal to 1/2. So 1 plus 3, how much? 4. Number of atoms per unit cell is equal to 4 in FCC. Then third one, end-centered cubic unit cell, ECC. Here atoms are arranged at the 8 corners of a cube. Okay, 8 corners of a cube, and its opposite faces or end center, opposite faces. So how can you calculate the number of atoms in ECC? Number of atoms per unit cell. How can you calculate per unit cell? How can you calculate? Answer, 8 corner into 1/8 part of an atom plus how many faces? 2 faces. 2. Contribution of atoms face 1/2. So 1 plus 1, how much? 2. Clear? Clear? Then these are the different types of unit cells. Then we can conclude that number of atoms per unit cell. How much? In SCC, how much? 1. BCC, 2. In body center, 1. Okay, body center 1. Then face center, FCC 4. Then in face center 3. Then alternate phase 1. ECC 2. EC, how much? 1. That is equal to this one. Okay. Then by using this number of atoms per unit cell, just one problem. That is, if three elements, what are the 3 elements here? We discuss P, Q and R. Then element P are arranged, or atom P are arranged in at the corners of a cube. Corners of a cube. Okay, corners of a cube. Then Q at its body center. R at its face center. Okay. Then what is the molecular formula? Then how can you derive the molecular formula? Molecular formula formed by the combination of these 3 elements. What are the 3 elements? P, Q and R. Simple. P atoms are at the corners of a cube. Corners means here SCC. So how many number of P atoms? P1. Clear. Then Q at the body center. Body center means how much? 1. So Q1. Then R in face center. Face center means 3. So R3. Then molecular formula is equal to PQR3. Clear? Okay. Here we discuss about unit cell. Next part. What is meant by close packing? Next section. What is close packing? What is meant by close packing? If we know that in solid the constituent particles are closely packed. Okay. In solid the constituent particles are closely packed, leaving the minimum space. That means in solid molecules are closely packed, so the vacant space is minimum. Here we consider the constant particles as an identical spheres. Constituent particles are considered as a sphere. So the arrangement of spheres in a crystal lattice is called close packing. Constituent particles means atoms, molecules or ions. Here we consider as a hard spheres. Okay, hard spheres. Then the arrangement of these spheres in a crystal lattice is called close packing. Then what are the different types of close packing? First one dimensional close packing, one-dimensional close packing, two-dimensional close packing, two-dimensional close packing, and three-dimensional close packing. Three-dimensional close packing. First we discuss one-dimensional close packing. Simple. In one-dimensional close packing, spheres are arranged only in one direction, only in single row. Clear? That is like this. Then spheres are arranged only either horizontal or vertical, or that is in single row. Then here we consider this sphere. Then how many number of touching spheres are present around the considered sphere? How many number of touching spheres are around the considered sphere? Here 2. So its coordination number equal to 2. Coordination number means number of touching spheres around the considered sphere. Then this is the layer A, then spheres A. So this one-dimensional close packing follows the pattern A like this. Okay. In one-dimensional close packing, spheres are arranged in a single row, either horizontal or vertical. Then its coordination number is equal to 2 because the considered sphere is surrounded by 2 touching spheres. Okay. That's about one-dimensional close packing. Then second one, two-dimensional close packing. In two-dimensional close packing, spheres are arranged in two planes, horizontal and vertical, like this. Now this arrangement, then what is the difference between these two arrangements? Okay, first one, this is the first row A, then second one also A. That means two-dimensional close packing are classified into two types. First one, here horizontal and vertical alignment of each layer is same. Horizontal and vertical alignment, one above the other. Horizontal and vertical alignment of each layer is same. First point, horizontal and vertical alignment of each layer is same. Okay, horizontal and vertical alignment of each layer is same. Then here we consider this sphere. Okay, this one. Okay, then how many number of touching spheres are around the considered sphere? Touching spheres 1, 2, 3, 4. Clear? So its coordination number is equal to how much? Coordination number is equal to 4. Clear? Okay, then coordination number is equal to 4. Next, here we joined these 4 numbers to get a square. So this type of close packing is called square close packing. Square close packing means SCP. Square close packing, that is SCP. Clear? Square close packing or SCP. Clear? Then second one, then in square close packing, next point, in square close packing, it follows the pattern A because horizontal and vertical alignment of each layer is same. Second one, next, two-dimensional close packing are classified into two types. First one, square close packing. Second one, here we consider first layer A, this one second layer not similar, B, then this is similar to that of A. So it follows the pattern, this type of close packing follows the pattern AB, like this. Okay, then horizontal and vertical alignment of alternate layer is same. Alternate layer is same. Horizontal and vertical alignment of alternate layer is same. Then here we consider this sphere. Okay, this one. Then how many number of touching spheres are present around the considered sphere? How much? 6. Okay, 6. Then its coordination number is equal to 6. This structure is similar to that of a hexagon, so this is called hexagonal close packing. Hexagonal close packing, that is HCP. Okay, this is something about two-dimensional close packing. The next class we discuss three-dimensional close packing. Thank you.